suppose we have some vertices, okay? It is the most basic in round ones. Usually this one is useful. For example, we have this one and this. It is 1, it is 2, it is 3, it is 4, it is 5. Do you know degree of 1 is what? Degree means what?
Degree 3. Degree 1 of.
Exactly. D2 is what?
I saw it in your video.
Okay.
3. 4.
4. D3 is what?
1.
D4 is what?
2.
D5 is what?
That's 2.
Yes, because two edges are connected to this vertex. Now, number of edges equal to what?
Sigma di over 2.
Yes, here if we count 1, 2, 3, 4, 5, 6, and if we check, we can see E is equal to sigma di over 2. Let's check it. 2 plus 2, 4, 4 plus 1, 5, 9, 12. 12 over 2, 6, right? That's correct. 12 over 2, 6, okay?
Yeah.
Okay, this is the first thing that you should know. Now, let me check one problem. Next idea is a bit harder. So, let me tell you also next idea because we need that. Have you heard Mantel's theorem?
I never heard of.
Okay, it is Mantel's theorem in graph. Sometimes we have special cases of that. It says what? It says G doesn't, G has n vertices and doesn't have a triangle. Triangle means what? Means 3 vertices that are connected like this, okay?
Oh.
Then prove that E number of edges is at most n squared over 4. We want to prove this, okay?
Okay.
Now, because this one is a bit hard, let's check some cases.
Because di can never be 2, right? Like for di for 3 vertices, at least 3 vertices cannot be 2. Then that's okay.
Di can be 2. Let me show you. For example, look. In this figure, for example, if you have 4 vertices, we can have this, right? It is 3. But we cannot connect any of these things, right?
Yeah.
Or you can have, for example, this one, this one, this one, this one, this one, and then this one also is good, right?
Yeah.
So if you have 4 vertices, this will be what? N squared over 4.
N square over 4.
We should prove n is number of vertices. Okay, n vertices. So if you have 4 vertices, we should prove it is at most 16 over 4, 4. So let's find an example with 4. We should connect which vertices to reach 4 edges.
1, 2, 2, 3, 3, 4. And
Yes,
4.
like this one, right? Or we can also draw like this, right? Both of them are correct. Now let's consider, for example, we have 5 vertices, okay? It will be 25 over 4, which is 6 point something 6. So do you agree if we connect? We should connect which vertices to which vertices?
1, 4, 2, 5.
Yes.
3, 5, 3, 4.
Yes, you can connect all these 3's to all these 2's. So do you agree you could find an example? And it doesn't have any triangle, right?
Yeah.
Because when you want to have triangle, for example, here, but we don't have any edge in the parts, right? So now can you tell me example that E is equal to floor of n squared over 4?
Okay. Just the last one, the one you just did.
Because we have floor, we should split up into which 2 cases for n to get rid of this floor. Exact. N is even. First, so n is 2k. So I want that you find an example with k squared edges. So we should do what?
And maybe just two vertices.
No, we have 2k vertices. For example, for 4 it is this. For 2k vertices, the graph should be like what? To have k squared edges. We can find the area by considering 4.
Teacher, I don't understand the question.
I said, suppose, for example, here we have 4 vertices, right?
Yeah.
And we wanted to draw a graph with 4 edges by considering this. Without any triangle, okay? So it was
Okay.
our example for N4, right?
Yeah.
I want to generalize it for even numbers. I said suppose n is 2k and we want to draw a graph that number of edges equal to k squared. So the graph will be what? For example, here we have 2 vertices in first part, 2 vertices in second part. We consider all edges between them. Then we have 4 edges. If we want to generalize this idea for even number, it will be what?
K vertices on top and K vertices below.
Exactly, and we call it bipartite graph. And we consider all edges between them, right?
Yeah. I
And
think I heard of this before.
okay, and n is odd because sometimes they won't tell you in terms of n. They will tell you, for example, a problem that related to numbers. Suppose n is odd, n is 2k plus 1. Then e is 2k plus 1 whole squared over 4. Then it will be what?
K squared plus K plus 1 over 4. So K squared plus K.
Yes, so the graph will be what?
So K plus 1 on top and K.
Exactly. So we found a graph with this. Now we want to prove why there is no other graph that satisfies this condition and number of edges be greater than this. Okay? We only considered when what happens when equality holds, right?
Yeah.
Okay, so let me tell you proof of this. It can be good for proving something. You know induction is what, right?
Yeah, you've taught a bit of this before.
Okay.
For number.
Yes. For graphs, one important point is hang out from a vertex, okay? And I will explain it means what. It is so much, so much, so much important. I can say most useful idea in graph is this. Means what? And sometimes hang out from a maximum degree, okay? Maximum degree, we call it delta, big delta. It means what? For example, here, maximum degree is what if you consider all these degrees?
Maximum degree is 4.
Yes. And we write it with big delta in Greek letters 4. So sometimes I say, okay, suppose that we have a graph that doesn't have any triangle. We want to prove number of edges is at most n squared over 4, right?
Yeah.
I say, okay, consider vertex 1 without loss of generality. Consider that vertex 1 has maximum degree, okay? So it is connected to 2, 3, 2, delta, right? Delta plus 1, right? Because degree is delta, right?
Yeah.
How many vertices are left in terms of n and delta? We have n vertices in total. Delta plus 2 to n. These vertices, how many vertices are there? From delta plus 2 to n, how many vertices are there?
I don't get it.
Look, I said, for example, suppose degree of 1 is 5. So 1 is without loss of generality. 1 is connected to 5 other vertices from 2 to 6, right?
Yeah.
So how many vertices are left? 1 to delta 1 plus 1 to delta plus 1, then delta plus 2 to n are left, are not connected to 1, right? These are neighbors of 1. So here, how many vertices are there? Delta plus 2 to n.
But how would I find n?
No, in terms of n and delta. Your answer should be in terms of n and delta. So it will be n minus in terms of variable.
N minus delta plus 2 plus 1.
N minus delta minus. It will be n minus delta minus 1, right? N minus delta minus 2 plus 1, n minus delta minus 1, right?
Sorry, I thought it was a number.
No. In terms of variables. It's good because some problems of also round ones are related to variables. It's good to. And so here, I want to calculate number of edges, maximum number of edges here, right?
Yeah.
Okay. Do you agree? How many? Do you agree here? We don't have any edge. Why we don't? There is no edge here.
Because this cannot be triangles.
Exactly. We can't have triangles. So here, how many edges do we have?
Uh, delta plus 1.
Delta. Because 1 is connected to delta vertex. So 2 to delta plus 1, right? So these are black edges. Now let me show other edges with blue. Other edges can be here or for example the one of them connected to one of them, right?
Yeah.
We don't have one is not connected to any of them. Why?
Because then there will be a triangle.
No, not triangle. Because all of the neighbors are here. We consider all of neighbors of 1 here, right? So the vertices that are left are not connected to 1, right?
Yeah.
Okay. Now, the edges that are left, let's color them with blue. Do you agree 1 point of each of these blue edges? At least 1 point. Let's consider A, B. At least 1 point of these blue edges are in B, right?
Yeah.
Okay, so if we consider some of the degrees of these vertices here, do you agree we calculate each blue edge at least once? If we calculate some of the degrees in B, exactly, it is at most n minus delta minus 1, and we know maximum degree we said is at most delta, right?
Yeah.
Now, when we calculate this, we are calculating these edges twice, these edges once. So we are calculating each edge at least once, right? So we can say E is at most this, right?
Yeah.
Now, if we factor from delta, it will be what? Delta times what?
N minus delta.
And sum of them is equal to n. When sum of two variables equal to a constant number, maximum product is when what? They are near to each other or far from each other.
They are far from me. No, they're near each other.
Near each other. So when they are near to each other or when they are equal to each other, it will be what the product? We can say it's at most what?
If they're near
In terms of n. In terms of n.
Oh, then it could be delta over 2.
No. In terms of n. Look, delta is a variable. N is constant from the beginning. Number of vertices. Okay? Delta is a number. Delta times n minus delta. This product, maximum of this product is what in terms of n?
How? Which inequality do I use?
For example, let me ask you this. A plus B is 10. Maximum of AB is what? Yeah, it's 5 times 5, 25. You should use exactly the same thing here. But here, instead of 10, we have n.
N square over 4.
Exactly. N squared over 4. N over 2 times N over 2, right? So we proved Mantel's theorem, right? We wanted to prove that E is at most n squared over 4, and we proved that, right?
Yeah.
Okay, now let's use these to prove two problems in graphs. Um, this one. See, why is it so much small? Let me it. Okay. What happened? Let me check it. Okay. So page, up on page. Okay. Uh-huh. Okay, now let me copy this one. Okay, it says A, B are so much easy. So try to solve first A, okay, and tell me the answer is what?
Three handshakes.
Three handshakes. Careless mistake. Try again.
I don't know where the mistake is.
So can you explain your answer so I tell you your mistake is what?
The degree of the graph is 6, and then we have to find the number of edges. So it's
So why sum of the degrees is equal to 6? Can you explain?
because A should only 1, so there will be one degree.
It says degree of exactly one person. This one has degree 1, A.
So
Then what about
yeah.
B and B?
Oh, okay. So it would be 4. That's 4.
Yes, 1 plus 2 plus 2 plus 3 plus 0 over 2, right?
Yeah, I
It is
forgot to read bin and colors each.
okay, so read the problem completely. And now try part B first on your own.
It's not possible because the sum of the degree divided by 2 is not an integer. So the number of handshakes is.
Yes, because we know that sigma di over 2 is number of handshakes, right?
Yeah,
And it should be integer, right?
yeah.
So means some of the degrees should be even always, right? In all graphs. And here some of the degrees will be what? In case in B.
2e. It will be 27.
Yes, 9 times 3, 27, which is not possible. It should be even, right?
Yeah.
Okay, now try part C.
Teachers, m equal to 3.
It is equal to 3, no. One hint.
Can I try again? One more.
Okay, sure, try again. You should use what theorem for this problem? You should use one of the theorem that I told you. Exactly, Mantel's theorem. Okay, so keep trying. Let me know if you want it.
Is the number of handshake at least 6?
No. One hint. Let me tell
Is
you
it
some
12?
hints. Here it says what? For C, let me. It says we have 7 people. At least one handshake occurred within each group of 3 people. So it means that we don't have this, right? We don't have 3 people. So in if our main graph is G, in what we don't have, there is no triangle.
Teacher, wait, why is there no triangle?
Because the problem says we don't have this. Because it says at least one handshake occurred within each group of 3 people. So we should have at least one handshake. We can't have 3 people that there is no handshake between them.
Oh, okay, yeah.
So if our main graph is G, in what graph we can say there is no triangle?
I don't get it.
Do you agree in our graph we can have a triangle? We can have triangle. We don't have any problem, right?
Yeah,
In dotted lines, we don't have any triangle, right?
yeah. In the,
So you can say in complement graph, in G prime, there is no triangle, okay?
what's a complement graph?
You connect, for example, look, if we have here, we have something like this. If G is this, G prime is this, okay? We
So
connect,
what's
we
the?
connect vertices that are not connected in main graph.
Oh, okay. I see.
Okay, because we don't have any triangle in dotted lines, it means that in G prime there is no triangle, right?
Yeah, G prime there.
Exactly. And we know number of vertices is equal to 7. So by Mantel's theorem, number of edges in G prime is at most what?
7 square over 4.
Which is what?
12. At least 12.
Yes. And can you tell me number of edges in graph G and number of edges in complement, sum of them is equal to what?
The maximum number.
No. It is constant. Uh, we consider all edges in graph and in complement graph. So we are calculating each pair exactly once, right?
Yeah.
So it will be
So
what?
I just need 28
Why 28?
because the 1 plus 2 plus 3 that's all the way to 7.
Why
28.
why to 7? We have 7 people.
Yeah, 7 people.
So who is connected to 7?
Uh, because the number of edges is the number of edges must be everything must be connected in EG, the graph of EG plus EG prime.
Yes. So if you consider all of the edges in our graph will be what? It will be what?
Oh, 14. So it must be 14.
No. For example, when we have 4 vertices, how many edges are there if you connect all of them?
Um, 8.
It is 8 count.
1, 2, 6, 6, 6.
6.
Sorry.
For 4 it is 6. For 7 it is what?
For 7 it is. I need to work this out.
Okay,
I
sure.
need to. I want general.
Okay, sure. This part.
So it is 21.
Exactly. It's 7 choose 2, 21. Okay.
Because I did the n minus 1, 1 plus 2 plus 3, all the way to n minus 1.
Okay. So 7 choose to 21. EG prime is at most 12. So EG is at least what?
Is at least 21 minus 12, 9.
9. So if you want to find example, I told you in Mantel's theorem, if you want to reach 12, you should consider 2 parts. One part 4 vertices because we have 7 vertices, one part 3 vertices, right?
Yeah.
And then here, because e.g. prime, we want to apply Mantel's theorem for complement graph. So between these two parts, we don't have any edge, but between them we have edge, right? This, okay?
Yes.
And then it will be 4 choose to here 6, 3 choose to 3 edges, so 9 edges. It is the example also, right?
Yeah.
Okay, this problem was an example of Mantel and also some of the degrees. Now that you've learned these graphs,